Well, awesome. I think we're going to go ahead and get started. Thank you, everyone, for joining us today at the Alliance for Peacebuilding's Tech4Peace series, featuring an introductory workshop on GIS for peacebuilding. My name is Shazia DeYoung, and I am the Senior Research Associate with the Learning and Evidence team here at the Alliance for Peacebuilding. So for those of you who don't know the Alliance for Peacebuilding, we at AfP, the Alliance for Peacebuilding, is a membership-based organization with 150 members working across 181 countries to end conflict, reduce violence, and build sustainable peace. For those of you who are interested in our membership network and would like to join the network, we'd be more than happy to have you join us. Just please feel free to reach out. In terms of AfP and what we do, we at AfP build coalitions in critical areas of strategy and policy. We also push the peacebuilding field to develop an adaptive and rigorous evaluative culture. And lastly, we build powerful partnerships and networks to elevate the entire peacebuilding field. AfP was named the #1 global peacebuilding influencer and change agent in a recent report that was put together by Arcgis Foundation and FAS Research. We at AfP are also committed to capacity development field-wide across the peacebuilding field, especially in the design, monitoring, and evaluation space, the DM&E, MERL, evidence, learning, all those fun acronyms. As part of this focus area, we also initiated the Creativity in Crisis video series that highlights creativity and innovation across the peacebuilding field. And within the Creativity in Crisis video series, we also have a mini GIS series. So the series featured a variety of programming from remote sensing in Northeast Nigeria to mapping out the health infrastructure in Haiti to inform the government's response to COVID-19, to even coordinating vaccine efforts in Ethiopia. And it is in fact through the Creativity in Crisis video series that we were introduced to these lovely individuals and our esteemed speakers today from the Data Science for Sustainable Development, also known as DSSD. So today we have with us Josh Panganiban. I'm so sorry, I must have butchered his surname, but Josh, who is the Executive Director from DSSD. We have Laura Mills, who is also the Director of Data Science at DSSD. And we have Skylar Seats, who is part of the data and programming staff here at DSSD. So DSSD is currently working with AfP to build an interactive map for us to visualize AfP's vast and diverse network and extensive reach. They are also building an interactive platform for our Irene Peacebuilding indicator database. We cannot wait to share all this amazing work with you all once it is completed and be able to showcase all the amazing work these individuals have put into these projects. And they've really helped us to push on how can we incorporate GIS within the peacebuilding field and actually realize what a powerful tool it can be when used correctly. So before I pass it on to these lovely individuals, just a few ground rules. Throughout the session, the presentation and the live demo, should you have any questions, please do post it in the Q&A section of the webinar and not on the chat. It just helps us monitor the questions and make sure we've addressed all of these questions at the end, where we have time for a Q&A session. And lastly, if any of you are interested in, similar conversations and convenings, we at AfP do have a working group on digital peacebuilding that focuses on online conflict dynamics and how can we harness digital tools to amplify peacebuilding outcomes. You can find a link to everything I've mentioned on the chat in just a second, but with that, I pass it on to DSSD. Thank you.
And thank you so much for the great introduction, Shazia. As you mentioned, I'm the Executive Director of Data Science for Sustainable Development. And, we're just going to jump in and talk to you a little bit about, GIS and peacebuilding. So real quickly, we're just going to give you a brief introduction to what GIS is and remote sensing, some of the areas where you could find this spatial data. Then we'll talk about some of the GIS applications and what we've done in the past and what DSSD is currently doing. Then we'll take a quick break combined with an interactive exercise. Then we'll do the GIS demos with QGIS, Arcgis Online, and Google Earth Engine. And finally, some closing remarks. I'm gonna pass on to Skylar to just talk about GIS.
So first, we're just going to start off by talking a little bit about what GIS is to give you guys some background context. So GIS, or Geographic Information System, is a computer-based system that can be used to store, analyze, manage, and visualize all types of data with a geographical component. It's a way to map information against its geographical context to help better identify patterns, connections, and programming needs. GIS really helps to simplify large amounts of complex data into easy to understand spatial representations that allow you to see things beyond just traditional tables and charts. An important part of GIS is also remote sensing. So if you don't know, remote sensing is a tool that allows us to gain information about the physical properties of a location, including the terrain and developments that might be there, without having to actually be on the site physically. This is especially important and useful when political, economic, time, or geographical conditions make it difficult to travel to the site directly, which, especially in regards to a peace-building conflict or a peace-building situation, can be extremely useful. And with open source platforms like Google Earth and satellite imagery, accessing remote sensing information is extremely easy and feasible. For example, Landsat 8 is a satellite that captures imagery from the entire Earth's surface every 16 days and makes acquiring current as well as historical geographical data very simple. Remote sensing also can allow us to gain information beyond what the naked eye can see, like infrared bands, and algorithms through these programs can help to identify different types of landforms. So by combining remote sensing information with other forms of data through a GIS platform, like the ones we'll discuss later, we can match this data to its physical context and help better identify patterns that might exist. So just looking at where to get GIS data, there's a lot of different sources out there that are available that can help you find GIS data. Government entities oftentimes have a lot of information regarding spatial components of their areas, international organizations as well, user communities where users can post their own data that they have found or acquired from different sources into a platform where it can be open source and accessible to the general public. Universities also tend to have a lot of data, as well as data aggregators and online repositories that are open source, such as the various examples that you've seen on the screen. And we'll share all of these resources with you guys as well. But so there's a bunch of different ways that you can get GIS data very, very easily, very, very accessible. And here are just a couple examples. The different types of spatial data, essentially, spatial data is just data with a spatial element or a geographical or spatial component. So that can include images, lists of addresses or locations, as well as spreadsheets of data with spatial attributes. So maybe a county name, a country name, or a different code that can help identify the spatial component of whichever area you're looking at. You can also create your own data through crowdsourcing and citizen science, GPS data, survey data, which we'll show later during the interactive part during our break, as well as digitizing from georeferenced material, contracted satellite or aerial collections, so essentially getting data from different satellite or aerial means, as well as drawn point, line, and polygon features that are especially useful in the different GIS programs that we'll discuss later.
Awesome, thank you for that. And what we're going to talk about is quickly, how data science for sustainable development is being able to help nonprofits and other organizations, use their data to at least make more informed decisions and come up with much better solutions. What DSSD does is we aim to work with nonprofits or government agencies or even companies in developed and developing nations, but primarily those working in the sustainable development and humanitarian sphere. Our sell is there's a lot of maps that we can build, dashboards, we can help you with data collection, we can give you advice on how to organize your data, provide you with capacity building trainings, help you with analysis, and provide custom solutions that will help your operations do much better. So with that, we're just going to talk about the GIS applications that we can do and that we've been doing. And I'll just be jumping around since there's a lot of interactiveness where it comes with this. So to first start, we all may know that when you think about GIS and you think about mapping, it's a very static map. something that you can pull up on a PDF or something out in Google Chrome. The data is visualized very easily. It's pretty clear on what's being shown. There's a legend, a title, a brief description somewhere. And these are easily, you could produce this quite easily. And there's a lot of open source technology like QGIS where you can build these on, or Arcgis Online with ESRI products. But there are challenges that come with building static maps, such as you can't really manipulate the data on it. There's limited visualizations. If you put too much layers on, then it could get complicated and convoluted. And you also can't conduct a lot of data analysis live. The map is there as it is. And so how it is best applied is that you can make these maps very quickly and include it in grants, including in presentations. You can put it up on like a wall and make informed decisions on it. It's really good. And there's a low technological requirement in making these. And the analysis can be done while you're at the tool, or you can do it manually with the data up there. So for example, this is a project I've worked on with a global environment facility, and we were looking at whether chlorophyll concentrations were changing within this marine protected area if they were located near global environment facility projects or not. So with that, you could just look at the image itself and make a decision like, hey, there aren't a lot of chlorophyll where there are GEF projects, which could be good depending on what you're looking at. Next, we're going to talk about interactive maps. And I think these are the ones that we all really want and enjoy to see because they're up on our web browser. You can click around and play around, click on all the very specific data points, and we'll get to that. But the best benefit is that the data is very clearly displayed. You can do a lot of analytics and visualization, including charts, graphs. You can even make them move around sometimes, and you can provide real-time updates. As data comes in, that could update an interactive map from day to day or at real time. The challenge is that sometimes it could be costly to put these together. It does require a good bit of knowledge of the tool that you're using, or maybe if where you want to build it on your website, you'd have to understand some type of coding. But there are a lot of options, especially with ESRI, to build them out and have them easily put onto your website. And it does require some infrastructure, depending on again what functionality you want. So we're just going to jump into a quick demo of this. Let me go back, and I'll show you what that looks like. Share screen. Yeah, here we are. Yeah, so this is the interactive map I was talking about, where we were looking at whether cannabis arrests are related to areas that are predominantly less white or more white. And as you can see here in the city of Evanston, there are more arrests and citations that occur in places that are less white compared to one of those are less white. And so you can go around and play with the tool. Some places might not have data, but then some places, you could get really specific, but like the medium house, legal employment, it really depends on what variables that you want to include with all that. So now we'll go back to the presentation. Next is Google Earth Engine. And this is like a really great open source computational way to do a lot of analysis. And you're using a lot of the cloud computing of Google to do a lot of the analytics and looking at different size imagery and spatial data. So this is great because you could easily integrate it with other data sources that are that you can pull through the Google Earth Engine application, and really just have to apply and say like, hey, this is what we're doing with Google Earth Engine, and they will approve you for the most part. It can be highly technical. There's a large coding aspect to it, and the data visualization may not be as good as what you would see in interactive maps, but it is very helpful to doing large scale analysis. And we're going to jump in more detail about this in their demos, but when you're using it for monitoring and evaluation, you would be able to pull a lot of information from online, lay it out there in an easily built map, and then run that analysis. And so over here, we in the past we've worked on a project where looking at the global environment facility protected areas and seeing where they're located. all over the Democratic Republic of Congo. And what we can quickly do is, collect data and analyze it further, and maybe use like QGIS with Arcgis Online to do that type of analysis, and then eventually build out to an interactive map with much better functionality and visualizations. Next, we're going to talk about ESRI story maps, and these are really amazing at communicating data. It's like almost combining a news article with an interactive map, because you could scroll around a lot, and embed videos, embed pictures onto it. It's really awesome. However, there are some challenges where it does require a lot of design, because you'd want to look as best as possible, and it does take a while to load. So you would need a good amount of internet connection. And I think the best way that we can make use of this is when you're doing your monitoring and evaluation, and you want to communicate to your donors what the project was or what happened, then you'd be able to put it together in a story map. And I'll briefly demo you to what that looks like. Yep. So this is a full story map about GIS for racial inequality and justice. And we didn't build this out, but we thought this was a great example to show you what story maps are. Essentially, it tells you the full story. You can include a lot of different images on here. And then ultimately with the spatial component, when you go down to a map, it will quickly load up. Yeah, as you said, it takes a lot of bandwidth to get going. In any case, the best way it could tell you is a really good story that combined with a map. And you'd be able to get this link right in the presentation right afterwards. But, oh, there it is. Yeah, and the amazing part is, so you have this visualization aspect combined with text. And as you scroll to the text, the visualization changes to the information that you're talking about. And there you can go into more detail as you keep scrolling, and then it changes to a different city. It's really awesome and really great to build out, when you have the design skills and the opportunity to combine that with geospatial data. Now back to the presentation. Next are dashboards. So these have a lot of clear benefits. And I think when you think about an interactive map, you want it combined with the dashboards that provide updates with data in real time. And so it clearly displays you, a lot of information that's coming at. There are a lot of real-time updates. And the best thing is that depending what software you're using, you can be really flexible. I'll show you a dashboard later that's built out on our website, but that was built out, from the ground up. And it really could provide as much information as we need to build out those features. But one of the challenges is that it is highly technical depending on what platform you are using. For most websites like WordPress, they have built-in dashboards like MapPress or TablePress that you'd be able to use. But it really depends on how much you would be able to afford and what functionality you're looking at. And then after dashboards apply, there's a lot you could do with monitoring and evaluation with these. You would be able to put up all the data that you've collected and gathered and put it on an interactive map that people can see quickly. And they could automatically, show and you can make those decisions much quickly. And I'll just show you the dashboard that we developed right on our website. Oh, let me go exit out of this. Yep. So with this interactive dashboard, you're able to, select NDVI. You could, have this interactive map and the weight, like how many cells are attributed to, the specific metrics that you're having. So here we're showing the natural deviated vegetation index. I believe that's what it is. But you can also change around and maybe you want to look at population, how that's distributed, or you want to look at elevation. There's really a lot of flexibility you can do and many features that you can build out and add on. Now we're gonna go back to the presentation. And yep, right after the break, we're gonna go quickly into our demos. So, please take your time. And while you're having this quick 5-minute break, please click on the link and submit your hometown. And there we'd be able to show you, some of the quick ways that you can collect data using ESRI software. So please, we'll see you back in, let's say 10:26. That sounds good. Thank you. All right, welcome back, everyone. Thank you for all those results. And so as I'll show you is that, everything that you all submitted can be viewed here on ArcGIS survey 123. And let me move this a little bit. but we can get a good visualization where everyone's hometown is coming from. I see we have some people out in France and out in India, out in the Philippines. So thank you so much for joining us late at night, and down here as well. So I see most of us are in the US, but thank you. So this is just a good example of how data collection, on a GIS level is really quite easy, because what you can do with this information is you can export it out. And there's you can take in a CSV, Excel, a shapefile to bring into QGIS, really a lot of different ways. But okay, now I'm gonna demo to you our favorite open source software, which is QGIS, and how we can make a map out of it. So let me shut my screen real quick, and I'm gonna share on to a different window. All right. So what we're going to show you, if you can see that, is how to build out this map really quickly. And so as you can see, this map clearly communicates, where hospitals are located within this region of Nigeria. And there are buffers within the 25 kilometers off those hospitals. And all of this out is filtered based on each of these points are attacks that we've taken from the ACLA data set. And the remainder of the data is straight from OpenStreetMap. But we're going to show you really quickly how, as I mentioned, QGIS is quick, and you can, produce maps quite easily. And I'm just going to show you that. So let's bring this down, and we'll start off with, QGIS latest edition. It's a long-term release, and we'll start with the most simple type of data that we would all understand, which is, an Excel shapefile. I'm sure many of you are familiar with this, but most important components are the latitude and the longitude, because that's really what matters a lot when deciding, if something has a spatial component. So we can bring that in by going to layer. We'll add a layer, and then there we have the shape, we have the CSV, we have the coordinates, like the geometry, and add that in. Might take a while, and there you have all the points from the ACLA data set into Nigeria. And what we're able to do with this is also add in, a base map, so we can get more context on where this information is. So as you can see, you can scroll around the map quite easily, zoom in. Personally, when I work with a lot of data, I don't want it to be too big. So with QGIS, you can quickly change the symbology. And let's say I want it a little bit smaller, so let's make that 0.5. Oh, that's too small. Make it 1. And then there you have it. So we're going to focus in this region, since that's the part of the map that I've showed you. And what we're going to do is also bring in additional data, such as hospitals, which I mentioned is also from OpenStreetMap. And then I'll show you how with QGIS, you can do a lot of spatial queries based on different names and really filter out the data as needed. So since we're starting with the big ACLA data set, we're just going to open up the attribute table. And the attribute table is very similar to what you would see on Excel. It's just a lot of the tables and the different fields. And as you can see, here are the coordinates that we use to populate this data set. So we can just do a selection of the features of each point with a quick query. And this is going to be recorded too, if you want to look back at it, but there are also a lot of QGIS tutorials online that are free to use. So then we could go within this, and we want to look at attacks. So that would be the sub-event type, and it would equal. We're going to look at all the unique values, and we're going to see the attacks. And so we want to click select all features, and as you can see, they are all selected there. Right here in the map, they're all highlighted in yellow. Those are all the events that are categorized as attacks by ACLA. And if we want to just filter out that data, since we want to be only working with it, we can go and export it out. So we'll save those selected features. Now we can just quickly call it, let's say, ACLA_attacks. And the processing is quite quick, and there you have all the attacks only. As you can see, the data significantly decreased. So what we want to do next is try to identify, where these attacks are within 25 kilometers of hospitals. But before that, it's much better to have our hospitals looking like hospitals. So as I said, with symbology, we can change out what those icons look like. So we'll type up hospitals and yeah, make it the red cross. And there you have all these hospital locations. But as I said, we want to do our analysis. We want to find, where these attacks are within 25 kilometers. So what we would do is we would, go to vector. We would go and select a buffer. And for that, you have a lot of the fields laid out here that you would be able to select out, which, you can learn a lot of it online. But for the demo's sake, we pre-made the buffers for you. And they're all 25 kilometers of the area. And so now we want to know is, where or like, how do we just get these events that occur within these 25 kilometers? And for that, we would, use another tool where we would select these things based on location. And so, we go on location, select the features from the ACLED attacks, whichever intersect within the buffers. And we would just run that really quickly. And there, everything that's within that buffer is highlighted in yellow, and we can go export that out. So we can just save the features as, type out really quick, ACLED attacks within buffers, make this version 2. I think I have something sitting in the repository already. And there you have it. You have all the locations that it would otherwise, be there. And this is a much better looking version of where all these locations are and how they are filtered in. Oh, my apologies. And so there's many ways that we can get to the map we first showed over here, because here you have the transparency so that you could see the base map as well, and nothing is all convoluted and there's making the legend. So with that, we can we can go to properties, adjust out the fill, make it more opaque. Okay, apply. Yeah, and then that's just one easy way to make sure there's no overlap over everything. And then when we in terms of creating a map, I'm not going to show you since you can learn a lot of it online, but you would go to I'm trying to find it. This sorry, here you make a new map view, and then you'd be able to visualize it really quickly what this map would look like. Sorry about that. And then you'd be able to either take a screenshot or export this out as a PDF, and ultimately get your end result, which is something like this. Add a legend and the map as well. So with that, I'm going to pass it on to Laura Mills, where she will show you some of the some more higher functionality GIS tools that you can use, such as Arcgis Online and Google Earth Engine.
All right, hi everyone. So as Josh said, I'll be doing the next 2 demos. Let me just share my screen really quickly. All right. So, okay, welcome to the Arcgis Online demo for this webinar. And today we're going to use the ACLED data that Josh also used in his demo. And we're going to create an interactive map and then this final product, which you see on my screen right now, which is a dashboard. And as an overview of the software of this demo, Arcgis Online is ESRI's web-based platform for building and sharing interactive maps. So desktop GIS applications like a QGIS, which Josh just showed you, perform many of the same spatial analyses as an Arcgis Online. So I usually use QGIS for creating static map layouts, but I make a pivot over to Arcgis Online when I want to use an interactive map, and then also integrate that into a dashboard or a web application or another digital storytelling platform. Some of you might be familiar with story maps. So, and also one of the most common dashboards that you see around is Johns Hopkins COVID dashboard that was built using the same software. So with a subscription to ArcGIS Online, organizations can manage all of their geographic content like a really secure ESRI environment, but the software is provided to nonprofits, usually at a very low cost. So you can feel free to reach out to us at DSSD if you want more resources regarding that. And there's a lot online about it as well. So we definitely recommend getting an ESRI license if that fits the needs of your organization and your work. So in this demo, we're going to learn how to write different expressions to filter the data, and we're also going to look at something called smart mapping. ESRI smart mapping functionality allows you to compare multiple attributes at once and find unique relationships that you wouldn't otherwise see in a tabular data set. So, and then our interactive map will be transferred over into this type of dashboard, which you can see on my screen. It has a really simple interface, user interface, and just all around really easy to use. It's a drag and drop environment. So I'm going to make a switch over to the ArcGIS Online interface, and I just want to point out a couple of things. So on this left panel, you have all of your data that you load in. This right here, I have it set up into different steps, but I started by loading the raw ACLID data. And you have your map visual over here. The data populates onto the map, and then a couple of different functions. But the ones that are going to be pretty essential for today, if you add over here, you can either access ESRI's data catalog, which has a lot of preloaded data sets. So that can be anything from census data to satellite imagery, topographical data, climate variables. So that's great. It already has data preloaded in. But what I did in this demo is I downloaded ACLID's data from their website and I added the layer as a zipped shape file. So that's going to be important for adding your own data and then visualizing it, manipulating it, and analyzing it further. So for the sake of a very specified analysis, we're going to be focusing on fatalities and violence in Nigeria attributed to Boko Haram, one of the largest Islamist militant groups in Africa. So violence, conducted by this group is not holistically interpreted through a spatial analysis. It's just another tool meant to expand upon the data, interpret it differently, and find a lot of visual trends. So it's a pretty sensitive topic and sensitive data, but it's supposed to kind of show you other ways you can look at it differently. But once I added a layer from a file, because all of this ACLID data is geocoded, meaning it has a longitude and a latitude, it was automatically populated onto the map. So right now you can see just every single event in the ACLID data set on a map, and I used a grayscale base map. But how do we kind of work with this further, filter it down, as I said, by actor, but also by country, which will be Nigeria. So first we're going to filter, and there's a difference between like a spatial filter and an attribute filter. But for a spatial filter, we're going to limit this visual view to Nigeria. So once you're in the raw data set, you can go to this filter function, and every expression that you write for a filter is separated into field type, operator, and value. So in this case, and I'll go back to the data really quickly, but this is like the tabular format for the data. So you can see you have your country column, you have your administrative boundaries, all of that, and that can be changed, kind of formatted differently in the filter function. So you would choose country, you would choose your operator as is, and then you would just type in Nigeria, and then that would limit all of the data to Nigeria, every event that happens there. And I have that preloaded right here. So this is a little better to work with. It's not just every event in the world, it's that visual view, but it also filters down the data set for you in a really kind of easy expression building environment. So you can also stack filters. You don't need to just apply one filter at a time. And so we're going to do the same thing with actor. If you go, I have it preloaded here too. This is how I filtered by both country and actor. So I wanted to limit all of the events to ones attributed to Boko Haram. So I found kind of what that unique name for them, for that group, was in the data set. And I applied 2 filters and stacked them on each other. So every event is one that happened in Nigeria and attributed to Boko Haram. And so once I applied that filter, it was able to isolate the data to all of these events sort of in the northeastern region of Nigeria. So this is pretty interesting. It's all kind of spatially, it's not very spread out. It's all kind of clustered together. So right now we're just looking at it as black dots and location data, but how do we sort of contextualize this more? I think it's helpful in and of itself. When you click on a dot, you can, or a point rather, you can see all of the information associated with that event. But this is helpful in and of itself, but how do we make it even more helpful to an audience member, someone who's viewing this, who isn't maybe as GIS literate? So what we can do is change the style of how we do it. And ArcGIS Online is pretty essential for the flexibility it gives in different style choices. So when you navigate to change style, which is right next to, here, I'll go here. What you can do, as I said, it's showing a location. So every point by its longitude and latitude as a black dot. But what you're able to do is pick an attribute and then visualize by what that data attribute is showing. So if I wanted to go to event type, and Aclid codes every event by, if it's a battle, they have about 6 categories classifying what type of violent event it was. And when you choose an event type, this is categorical data. It's going to give you different drawing styles. So right now, this is made so every event type is a different color. So there's no hierarchy. You can really customize whatever colors you want. But right now, if it's pink, it's battles. If it's purple, it's strategic developments. This sort of just categorizes the data in a visual standpoint. So this is cool. This is categorical data. But what if you want to look at fatalities, which is numerical data? So then again, you get a bunch of different drawing styles that are specific to that type of data that you're showing. So one is colors and amounts, and the larger the point, the more fatalities that happen there. You can look at colors and amounts, so it's on a color gradient. The darker the point, the more fatalities that happen there. You can look at a heat map, so it shows the hot spots of fatalities. So this is really interesting, and whatever fits your data, you can show it there. So we're going to stick to colors and amounts, and I have it loaded. So this is by event with the categorical and color data, and then this is by size. So you can keep them separate, but just in the same way as you stack filters, you can also stack style types. And this is what I mentioned before as smart mapping. There's ways you can compare different style types for attributes and sort of see how they play off of each other. So what I'm going to do is, of course, you can add multiple at a time, and you can combine style types. So right now, it still changes. So the larger the point, the more fatalities, but then it's also classified by its event type, as seen here. So these two style types really play off of each other. And it's just an interesting way to interpret your data further. Another thing I also did is before in the original data shown here, when you click on a point, as I said, it's the reformatted table. So it's just 2 columns, and it shows really everything attributed to that data. So some of these things might not be essential when you make your final product, which is the dashboard. So you may not want to know certain things. You might already know that it's Nigeria. So how do you limit this? And I won't show the specific process, but there are ways you can configure pop-ups to only show the information that you really want to know. And that's exactly what I did here. So when you click on an event, you see all of the notes and the description of the event. You also see the location, and I wanted to know the timestamp, and I wanted to know the number of fatalities. So once you create this interactive map, you can keep it just like this and share it around. But the best way to present this would be, in my opinion, a dashboard. And so once you create it, it's really easy to just load it into this dashboard. You can add a title, you can add a subtitle. I made a chart down here. It's responsive, which is always a plus. And then you can also look at your legend. You can scroll in, zoom in and out, interact with the data, see it in the same format as before. And this is a very simplified version of something you can do, but it just has a lot of options for presenting your data. Smart mapping is really essential to seeing different visual trends. So that concludes the ArcGIS demo. And next, we're going to move over to Google Earth Engine, which is actually very different, but similarly the same way you can display your data. So I will make that transition really quickly. Okay, and I just want to preface this by saying this is my favorite platform in the world. But first of all, welcome to the Google Earth Engine demo now. First, I'm going to give you an overview of the interface, what it's used for, what type of analyses you can use on it. And really, we'll use the ACLID data again and try to display something totally different from what I displayed last time with, code. So first of all, Google Earth Engine is a planetary scale platform that hosts just the most extensive catalog of open source geospatial data sets and satellite imagery. Most of you are probably familiar with Google Earth, which allows you to look at geospatial data on a virtual globe and really move around that globe. But this is Google Earth Engine, so it actually harnesses like an API to access, visualize, and then analyze geospatial data. So the API is very easily accessible. It's a web-based platform, open source, and it's a means of both visualizing and analyzing data in the Earth Engine catalog, or data that, of course, like in Arcgis Online, like in QGIS Online, you import yourself. So Google Earth Engine is most commonly connected to through the JavaScript or Python APIs. I personally use the JavaScript API. So it does require a bit of programming knowledge, and several JavaScript guides are available online to, I have one example here, to walk you through how to use JavaScript, but then also how to use JavaScript to write certain commands for the Earth Engine code editor. So when I started using Google Earth Engine, I had a couple months of Python under my belt, a bit of GIS knowledge. I went through every single tutorial and basically taught it to myself. It was very simple, and that's great. And now I use it for everything. But if you don't necessarily have the time for that, it's better to get someone who has that coding background, knows the terminology, kind of how to create different statements in JavaScript or Python, and then harness the Earth Engine code editor. So this demo won't necessarily be a code walkthrough, but it's going to be rather how my script produces what you see on the map. And we're going to be replicating parts of, oh, I forgot to pull it up, but here it is. Part of this analysis. So I found this on ACLID's social media, and I thought this was just the most fantastic study. It's everywhere on their Twitter, but what it's showing is Nigeria's abductions and forced disappearance events from 2018 to 2021. As you can see in this stacked bar chart, there's a huge spike between 2019 and 2020. You can look at the map and it sort of contextualizes this further. It separates it out by perpetrators and different actors responsible for these events. So I wanted to recreate this, at least parts of it, and try to show how Google Earth Engine is the platform where you can both visualize, you can create this and this at the same time, just in under like 200 lines of code. So that's exactly what we'll be doing. And as a quick walkthrough, this is just a data catalog for Earth Engine. So it's using a lot of conservation things too, with Landsat and MODIS, but it also has demographic and other geophysical data. So this is nighttime lights, which a lot of you have probably heard of. But anyways, to the demo. So right now, just as you saw in ArcGIS Online, all of the raw data is loaded in. On this left panel here, I was able to upload the data as a shape file. And as a quick overview, these are all the scripts I've ever written. This is documentation for the code to help you. It's very quick access. This is where you write your script. This is where you print things in the console. And then the map is also where you can visualize data in the same way you would write a print statement. So I have it all visualized in red. Let's apply a spatial filter and an attribute filter again. So this spatial filter will be Nigeria. Just as in the ArcGIS Online tutorial, instead of writing the expression in a sort of like a box that I found, you're going to write it separately as lines of code. So I was able to pull in boundaries for Nigeria and then limit the data to all of the events in Nigeria, but also all of the events associated with a sub-event type, abductions and forced disappearances. So that was done just in a few lines of code here. So I was also able to calculate a histogram and to show the events per year. So as you saw in the stacked bar chart before, there's a huge jump between 2019 and 2020. I also put this in a chart and you can access it here. I have it loaded here. So just as in ArcGIS Online, there's the table, or every chart and visual that you print are responsive. So right now you can click on and see that there are 210 events. You can see it per year. You can also customize these visuals and with the title, with the different axes. Another great thing, you can download in 3 different data formats. So you can extract this right from Google Earth Engine. So either analyze it further there or extract it and analyze it on another platform. The CSV is something that I always export. But so a couple of things about this histogram. It's actually really interesting. This is a huge data insight in and of itself to see that the number of abduction and forced disappearance events in Nigeria more than doubled between 2019 and 2020. So this is super valuable in and of itself. But how do we get a little more granular with this analysis, a little more specific with it? And so we're going to separate it out by perpetrator, which is exactly what ACLID did to, as I said, give context and specificity to this type of chart for people who are really concerned with, this crisis and what they can do about it. So what I did first is I printed all of the events associated with about 21 unique actors within Nigeria. So you can see that the bulk of them were associated with unidentified armed groups in Nigeria, and then a lot were associated with communal militias. Islamic State had a bunch. So we're going to separate these out by years and then try to visualize it in that bar chart again. So a bit of separate JavaScript knowledge was needed to separate these into the 6 categories predefined by ACLID. So it was state forces, other, communal militias, Fulani ethnic militias. So I looked at those 6 categories and grouped them, those 21 actors themselves. But so I won't go over how I did that, but what I had in the end was every year had, this is category 1 of perpetrators, this is category 2, category 3, onwards for every year. And then I was able to, in the same way I created this chart, I was able to create this stacked bar chart, which has here. So I looked at it further, and this is the final product. Again, it's responsive. The only difference, it's exactly like the one before, but separated out by perpetrator. So this has a lot of different insights that you can see. And one of them is state forces were responsible for the bulk of a lot of abductions in 2019. They basically had no presence in 2020, according to this data. So that draws a lot of different questions and next steps. And it's just a different way to sort of visualize your data. So let's also pull in the geospatial element of this a little more towards the end of this. So once you kind of look at this, you might want to visualize these better and group them by perpetrator. So right now, every event is just a red dot. But in a couple more lines of code, what you're able to show instead of those red dots is have each one separated out by perpetrator. So it's slowly populating the map with those. So you can see that unidentified armed groups were really present in the south here, sort of central Nigeria and up to the north. Communal militias were seen in this northern region. You have the Islamic State and or Boko Haram over here. You have state forces down here, or Fulani ethnic militia. I can't differentiate between the blue, but you can also separate them out a bit more. It just contextualizes your data. As I said, Google Earth Engine, you can do this same analysis in a couple of different platforms, but for someone like me, I prefer to code when I do GIS. So this is really the platform I would use to have everything in one place. And I also use this to pull in large amounts of data, satellite imagery, and run really large scale analyses over huge geographic extents, huge numbers of or long periods of time. So this is really one of the best platforms out there, and I hope this was helpful and not too much, too overwhelming. But that really concludes our demos for today.
Awesome. Thank you so much, Laura. And we'll just jump right back into the presentation and just talk briefly more about next steps. Let me go back to sharing the screen. Yep. And so as you can see, we are very ready to help and support you and your organizations and the projects you guys are looking to deliver. We think GIS has a really big value when it comes to evidence-based decision making and really visualizing where things are located and being able to make those decisions quickly. With satellite information and a lot of data coming in, you would be able to respond to the changes that happen But you'd also be able to visualize where that is happening and think about it much quickly. Also with GIS, you'd be able to expand your portfolio and add a spatial component to your projects, being able to show it off to more people and possibly your donors, because it's really good having the visual component, even if whether you're working in monitoring evaluations or you just want to show where all your members are at. So the idea of GIS, that is a strong visualization tool and also with analysis. And we really, as data science for sustainable development, want to work with you. We want to help you in your projects and help you do your analysis and build up that area of peace building or any other part of sustainable development, where we can use all the spatial data that's been already collected in the world that are open source, and help you deliver on whatever you're aiming to do towards. So we offer both contracted technical support, where we can quickly turn around a project, help you build out web apps on your website and even mobile app development, and we'd be able to provide that long-term support for your organization. But also, if you're looking for a project and you just haven't had the time to build out, then we can also connect you to our network of volunteer individuals that do GIS with much more defined projects and which can fall within specific cycles. So please reach out if you want either or both, please. Yep, and so please, we want to leave this part of the session for the last 15 minutes for any questions that you may have about us. But also, if you come up with anything, please shoot me an email and also check us out on our website. So anyone have any questions, please ask about. Thank you.
I think we have one question from Raju who's raised his hand. Okay, I'm gonna try and see if I can get you to speak. But if not, can you post? Okay, here we go. You can ask your question, Raju.
All right, thank you so much. Just wondering, do you work with different geographical areas? And can you work with nonprofit companies and profit companies? Thank you.
Of course. We can work with anyone where they're located. I'm actually not even a U.S. citizen. I'm just here for my education. I'm based out of the Philippines, so we're very used to working, across all types of time zones. And nonprofit or for-profit, it doesn't matter as long as you're a mission-driven organization and you're looking to make an impact in the world.
Thank you very much.
Of course. And maybe we can, anyone have any questions, please just drop in the chat and interrupt us. But Laura, maybe we could talk about some of the current projects that we're working on, especially in the Philippines. So for example, we're working right now with a renewable energy company called One Renewable, and we're helping build out this interactive map where users could submit different companies could submit data of where their solar projects are located all throughout the Philippines. And so we're trying to build out the functionality of this map so they can bring it to the Renewable Energy Association of the Philippines. From there, we can get buy-in from the community and eventually in display where all these solar projects are all throughout the world. And that would really help, gain investing in solar and renewables all throughout the rest of the country.
Yeah, and it's quite a unique project also because we went into it thinking we were going to do it one way and just use the dashboard on ESRI, which I showed. But actually the data that they wanted to show and the maps they wanted to create had more of a narrative aspect to it. So we sort of made a pivot over to story maps on not Google Earth Engine, on ESRI. So that's more of a digital storytelling platform, and it best accommodated their data. So that's really interesting. It's going to be more visuals based. So a lot of pictures, a lot of videos, a lot of maps, of course, that you can navigate yourself. So that's different from a dashboard, which sort of has all of the numbers jumping out of you. It's not very it doesn't have that pictures, and it also doesn't have quotes. And it's basically like, if for those not familiar with the story map, it's really sort of that one-page website, and it's beautiful, and that's what we're going to create for them. So that's what we're working on now in sort of interactive maps. Another recent project that we finished up was with the Global Registry for Violent Deaths. That was creating static map layouts, and Josh and I worked a lot on that. That involved, so you saw in the ACLID data, there was actually a variable for geo-precision and time precision. So when you look at it, so with violent deaths, it's, that they happened, but you don't necessarily know when they occurred, or, where they occurred, of course, and then when they occurred. So there are different levels of geo-precision that come with it, and where we know an exact violent death is. So the challenge there was creating maps per a lot of different countries. We looked at Sri Lanka, the Philippines, Mexico, for example, and we're looking at how to show the uncertainty in that violent death reporting as a way to get more resources for grieved and expand this project. So in the future, all violent death reporting has the highest geo-precision and temporal precision possible. So that's an example of more of a static map project that we're involved in.
Yep, and I see Alex post a question, then we can go to Raju, because I think he raised his hand again. The question is, when is the next event? And on me and on the data science for sustainable development, and like if you would like to host another type of workshop similar to this, or with different types of data, whether it's in conservation, energy, please, we can coordinate that. But that might also be an Alliance for Peacebuilding event. So maybe Shazi or Jessica, if you'd like to join in and speak upon that.
Yes, absolutely. Like I mentioned earlier, we do have a working group at the Alliance for Peacebuilding on digital peacebuilding that focuses on online conflict dynamics and the different tools and technology out there that we can use to harness for peacebuilding outcomes. So I will drop a link to the working group. If any of you are interested in joining that working group, please feel free to reach out to us at the Alliance for Peacebuilding. And I will also put in an email address for you to reach out to if you're interested in that. But that group meets more frequently. Yeah, thank you.
I think Raju had another question. He raised his hand, but correct me if I'm wrong.
Yeah, thank you so much for taking that question again. Just wondering, have you heard of the metaverse? The metaverse, and does some of the work that you do, can that be interfaced with like Facebook platform or other types of platforms? Thanks for taking another question.
A lot of the work that we do would typically be dashboards that you'd embed on your website, or we can hand you like a product, whether it's a PDF or if it's like some type of software that you need built out. And if it's on your website, then you could easily share that with Facebook or LinkedIn. But we don't currently know or are familiar with building out like GIS applications on the Facebook platform itself, or Instagram or any of that. But a lot of the work that we do is very shareable, especially when it goes up on your website.
And I just want to highlight that we do have another question in the question and answer section. If you guys wanted to address that as well. Do you have any example code which you either followed or a GitHub repository that you developed for the Earth Engine app or the other one, I don't know, late D3? And if you guys have an answer for that.
Yeah, I think we do. We'd have to talk to our software engineering side and have that put out, but we can definitely send you where our GitHub repository is, and have that code uploaded, since it is essentially open source. But yeah, we can send that along your way.
Yeah, and I can drop the link in the chat to that too, like the actual map. Yeah, that's an example of the really large amounts of scraping that you can do on Google Earth Engine. All of that data was collected on Google Earth Engine and then built on D3.
I do want to repose another question that was originally in the Q&A section in terms of any preferred open source interactive mapping tools or any softwares or platforms that you would suggest for, beginner users, first time users, how to get acquainted with GIS. Would you guys have any suggestions for where you would start out, which platform is most suitable for that?
Well, in terms of getting acquainted with GIS, I mean, a lot of my GIS knowledge has come from school, but that's limited to something like an ArcGIS Pro, ArcGIS Online. So there's a huge online presence for GIS that can extend to different forums, but I know that Skylar also posted about different professional networks or working groups related to GIS. One that I just joined this past week is a Women in Geospatial group, and we're actually going to be a part of their webinar in about a week or two to talk about conservation GIS. So actually, the more connected you get and the more you sort of look into different GIS applications, I think the more people you find, and there are a lot of groups that support GIS and people expanding their knowledge of it, but also getting GIS knowledge out to a lot of people who have a different variety of platforms that they're able to access. So that's what I would say. I found that a lot of people are willing to answer your questions online too. As a coder, I use Stack Exchange a lot. I also use GIS Stack Exchange. So the other day, the founder of Google Earth Engine answered my question. So people are very open to helping you out and getting in contact and sharing knowledge on GIS. So, and then I also mentioned before with something like a Google Earth Engine, which is for the computational geographer, it was something that I didn't necessarily have the background to look at kind of when I started a little while ago with it, but I was able to go through the tutorials and documentation online, just in the same way that when you code, you have a bunch of documentation available. It's the same for GIS. So that would be to make a long story short, that's really my answer to the question.
Sorry, I'm right next to a fire station, so that's what you hear. But I just wanted to give, we have a couple more minutes, and so just open it up. If anyone has any other thoughts, any questions, last comments before we close it up. And I see no takers. So I'm thinking everyone's really happy right now. Thank you so much for coming today, and for thank you DSSD and all wonderful individuals for speaking with us today, and awesome work that they're doing. I just wanted to remind everyone that this is live on YouTube, and everyone will have access to the recording after the event. If you choose to follow along with any of the demos and examples and want to play out with any of the softwares, especially QGIS, since it is an open software, you can always access the recording and click through following Josh with his example. We will also be reaching back out to the participants at AFP with links to the presentation and any other resources that were mentioned within this presentation that we feel would be useful for all of you to have access to. But I think with that, Jessica, would you like to say anything?
I just wanted to say thank you to everyone. I know there were quite a few questions in regards to next steps or future trainings or opportunities. When we send out the information, and probably around Monday, following up with some of the resources that have been shared to connect with all of you, we of course would welcome your thoughts, questions, comments, brainstorming on areas that you would like more shared knowledge opportunities on, both in terms of technology, but within the broader monitoring, evaluation, learning world. And it's something that we're looking to build out at AFP. So thank you all so much for your time today. And again, thank you to our great team at DSSD for the fabulous knowledge that you've shared, and certainly encourage everyone to reach out independently to them or to us if you have additional questions, and we'll make sure to follow up. So thank you so much. Have a wonderful day.
Thank you, everyone. Especially thank you to Alliance for Peacebuilding for hosting this for us.